Hi guys, welcome to Learn Electronics Repair. I have a PCB here. This is from the local builders, the one who build mansions for millionaires. It's some sort of controller, so he sent me a few pictures. I'll show you what this does. I have a good idea what this is for, and then we'll get on to the fault. So this is the PCB in the control box. You can see it. He thinks he has a burnt out component here, but looks like a MOSFET. Maybe he's right. So this is what it controls. This is like almost like a Venetian blind, but horizontal. A slatted roof, opening and closing Bioclimatic Pergolas, 2 motors, S1 and S2. And by the way, lighting up a few LED strips. Okay. And 3 steps dimmer maybe. Motors are in the Pergola, fitting the moving wings. It's 24 volts. So we know something about this at least. Okay, let's have a look at it. First thing that comes to mind is whatever's wrong with this, and this does look a bit burnt to me. Yeah, it's been working hard. The problem may be with one of the motors, so it could be that this is faulty, but it's faulty due to a problem with one of the motors. This says S1 and S2, but I would imagine it could probably connect either motor to one side and test them both. Yeah, maybe. So I can see the MOSFET. There's a chip here. Maybe this is what's driving them both. I'm just looking for the driver. Could be that. Okay. S1, S2 and output VDC, a voltage DC. Okay. And there's obviously for the Wi-Fi or radio remote control. Yeah, 455 megahertz, whatever these things are on, something like that. Okay, so let's just check first around here to see if there actually is a fault in this area. And we have 2 sides so we can actually compare one to the other. Yeah, makes life a bit easier. Right, let's see what we can find. If this is a MOSFET, it'll probably just read open. This would be the gate, you would think. Reads 1.459, but remember that's with the black on here. This is probably the drain. It's probably an N-type, so that's not the normal polarity this would operate in. Is this going to read? Yeah, parasitic diode. Can you see it there? In the reverse direction it would normally operate in. Okay. That you'd expect should read open, and it doesn't. And that reads like a diode. Let's look at the other one. There we see that same sort of reading again. Okay, go to the reverse polarity, black to the drain. Yeah, parasitic diode. We don't see a diode there. We don't there. So they read different. Different voltage drop there. You see that's like the parasitic diode. Gate 1.46. Remember this is physically the opposite way around. 1.5 reads a little bit different. Gate with a black reads like a diode, 597. And that doesn't, yeah. So they read different to each other. So this is probably faulty. I think after we solder that one, we'll get onto the component analyzer. What is this thing? Has it got a part number? I'm assuming it does have. 20R042 or VND14. How about the other one? Well, this has the conformal coating still on it. Obviously the other one's been running hot, but it looks like it's the same. I'll get this one unsoldered. We can add leaded solder to these. You see I've done that. I mean, this is obviously soldered underneath here, so you're not going to totally get leaded solder into lower the melting point. You can't get it under here. That means this will be a little bit tricky to unsolder, but if I do add some leaded solder, it will help. At least it will mean that the two legs there, the solder will have melted when this melts, so you shouldn't be ripping any pads off. Okay, I'll add a bit of flux to this as well. Okay. Yeah, it's flowing in a lot better now. Okay. I'm not going to put tape on this nearby component. It just doesn't really help me very much. I need to get some heat into the board. I'm going to heat up from like this side first. And once I get this to melt, it'll be easy enough to get the other side to melt, okay? That is definitely not easy to unsolder. It's off. Usually just when you think it's not going to come off, it comes off. Okay, that was with the hot air on 450 centigrade with my quick 861DW. Results may vary depending on what equipment you are using. Let's have a look. So there it is, VND14, I think. It's a little bit hard to read, VND14. Let's have a look at the other one, just to compare again. Yeah, that doesn't help very much because of this coating on it. I'll just try and clean that off with a little bit of isopropyl alcohol. Yeah, that is clear now, so VND14, but there's another number as well, so it could be the other one. Let's test the one we took off the board first, and then if it is faulty, let's find a data sheet. Okay, let's have a look to see what this component is. Well, it's an LED or diode junctions, okay? That's what it says it is. Let's see what it really is. I mean, it could be, I guess. I mean, the red is actually on the tab and the green is on there, okay? Well, I've searched for VND14. The manufacturer is correct, ST, suggesting it's an auto-protected power MOSFET. A fully auto-protected power MOSFET. The number is slightly different, but VND14 could just be the marking on the package. Okay, it's certainly the right package as well. And it's a bit of a strange device. So it's not like a MOSFET with gate drain source. It has some circuitry in here. So I don't think this would actually detect as a MOSFET if you were trying to measure that on a, for example, a component analyzer. Over voltage clamp, linear current limiter, etc, etc. Omnifet, how about that? You guys come across these before? I must admit, this is something new to me. Well, what I can say is I had some different readings on this one and this one. There's some difference somewhere. I can see the full number now, VND14NV04, which in fact does match the datasheet we were just looking at. So that's what it is. What I can say then is, I probably can't test this component on the analyzer. I see some difference in the readings I'm getting on this side and this side. But I don't know, although it's been running warm, if this thing is actually faulty. What I do know is that I can unsolder this one as well, and then the two sides should be the same. So if I then take readings around here, they should read the same, and both of these should look the same on the component analyzer. Okay, so let's do that. These are actually the same devices, this one and this one. Okay, this horrible coating has come off quite nicely now. I have to put something back on when I fix it, but never mind. At least we can see what we're doing. Let's look at this one. Oh, okay, so it does see this as a MOSFET, so you can test them then. Good, so we know the other one is faulty. Yeah, low gate threshold. But we know we can't just stick any old MOSFET in here. It has to be the right type. Let's see if this looks the same on both sides now. So I'm in diode mode. That reads open. Open. Go to this one. That doesn't read open, so something is still different here, okay? Yeah, there's a reading there, so something is different between these two. We still have something wrong. Let's look around these. Okay, what's this one look like? Well, that reads the same as that one. What's this thing? That's a diode in that direction. Same there. We have two more of these here. These are the same device as those. So there's some sort of diodes, these. Oh, that reads short. How about this one? That reads like a diode. So that is reading short. Both directions. Diode. Yeah, okay. There's something else here. That one, and that one, and that one. There's, okay, so there's four of these things. 1, 2, 3, 4. There's 4 MOSFETs, and there's 4 of these diodes. So I think we can say that circuit is the same, repeated 4 times. Yeah, we have these big power resistors. These should be short, basically. Probably current sensor resistors, I'm guessing. Okay. I'll remove this one and let's see again if they look the same as each other. I've just cleaned that up a little bit. Don't want any solder bridges while I'm actually just testing this. Okay. That looks like it's actually just part of the PCB, a track there, okay. Yeah, it does look like that's part of the PCB trace. If I check on the other one, so we obviously have a connection there to there. So it's the right hand leg. Let's have a look at this one. So from the main, yeah, that goes to there and there. Yeah, it does. So that looks like it should go there. Yeah. Last one. Okay, happy with that. Here's the diode. Now reads like a diode, so the short isn't in the diode. The short is something else. Okay. What else can we have here? Well, the short's still there. It looks like that goes to this thing. It must go to here. Yeah, and then this goes to here also, so that could easily be short. We can look at another one. This helps. So end of the diode goes to there, and this goes to that. Okay, so that looks like it's probably what's short. I mean, there's another capacitor here, and that reads not quite as short as that does. Oh, there's a low value resistor. That's a 10k resistor actually. That means that number. Let's just go back to ohms range, see what we have. So this reads 17 ohms. 17 ohms. Yeah, less. I think this is a MOSFET. You see there's like one pin here, which is probably the gate, and then drain source. That's how it looks. So if we go from here, yeah, that's a 17.5 we're reading. Both ways. Go to another one. So we have one here. So it was from here. Yeah, much higher. Okay. So it looks like we read a low resistance. In fact, we do, from the gate to here, which then tells me I need to find out what drives that. But next I need to take this off the board. This one, because it's close to this plastic and it's close to these, I will try to put a bit of Kapton tape on here. Yes. Yes. So the short's gone, so that's what it was. So we need to replace that. Now then, do we see any differences now? Bear in mind, some diodes are not fitted. Yeah. Check the meters working. Okay. Right. Gate to here. Open. All the way. Yeah. Reading climbing up. Open. Open. Okay. I'm not too worried about the reading climbing up. Something's charged somewhere. This will be the drain or source. So that reads open. Or if it climbed to open, this reads open. So here, open. Open. What about around these ones? So here, yeah, 1.52. Here, same. Here, like a diode. Like a diode. This way, yeah, 2.2, 2.3. Same. So those all read the same around those. Let's just look at these MOSFETs. So if I just find the gate, red on the gate, what do we have here? I'll go to resistance range. Reads open. Okay, this one reads open. This one reads open, and this one reads open now. Okay, right, so what's driving this? It must be this thing, I would expect. Oh, 1117. That sounds almost like some sort of voltage regulator. Let's get the microscope. So not 1117, but I117. Okay, some other letters. JSJ 602. It has like a little emblem on there, like a stylized M, maybe. We can try and find a data sheet for this, but I've got a feeling that this is driving these MOSFETs. Let's have a look. Yeah, this kind of looks symmetrical, if you see what I mean. We have a resistor there, the group there, resistors, capacitors. It all looks kind of symmetrical. I'll see if I can find a data sheet for this. That would help. But if not, I'll have a look around these components either side, and if I see the same readings in resistance range, maybe it tells me this is okay. This is driving that, and there was a problem on the gate, so it's quite possible that a fault here would damage that. What I would like to do with this, if I have the parts, obviously I'm going to change this one. It's faulty. The diode reads okay, but to be honest, if I have to order parts, if I can get the diodes, I'll replace it anyway. The same with this little MOSFET. I need to change that. We need to see what it is, find the data sheet. And I would like to change this as well. And then I've kind of like replaced all the silicon really. There's probably some little diodes, that one. Yeah, there's a little diode on each of the four. Again, we can just see if they all read the same. Okay. Let's see what this says. So 602 I117. I've entered the number I117 and found HI117, high sincerity microelectronics. Yeah, that's a transistor, so that's not what we're looking for. These are D2A converters, so they're not going to be what we're looking for. Also, the manufacturer, the logo doesn't look quite right. Adding the 602 just doesn't help at all, it makes it worse. Okay, so it doesn't look like I can find a data sheet for that thing, at least not easily. So let's go with the other method, which is to see if I find the equivalent components either side of here. Do I read the same resistance across them? If they read the same, it's probably okay, that chip. Probably, yeah. So this one reads 25K, 25K. I'm not bothered what the markings are, I just want to see, are they reading the same? 996, almost 1K. Yeah, same. This capacitor, 26K. This one, 1.018. Very close. Then we have a few more up here. So we have this 105, a 1 meg resistor. Yeah, 4 point something K. Then that must be the equivalent, 105. Reads the same. This 40C, 978. That's that one. The capacitor. Same. I think that's actually across that resistor. Same. This one. Same. I think they were in parallel. Looks like they are. Yeah. I see two more capacitors. There's only two of these. One of them's here. 1K or 1 volt rather than it's on diode mode. bit higher. Read it the other way around. I think it is mounted the other way around. Reads the same. Okay. So, best judgment call. That's okay. Probably. I don't know what it is anyway. So I need to go find some of the MOSFETs, the little one and the big one, and these diodes if I can. Otherwise I can put the other one back on again. It does read okay. What are they? So this one, U620. Yeah, rectifier diode. And the small MOSFET. Well, it's the same as the ones that are still on the board. HABO39 or 086P3N. It's probably the 86P3NE number. Does this one say? A little bit harder to read. Okay, at least I can read this one. Let's look at this one. So 086P3NL. More's the point, can I get these things? I can get the VND14, 10 pieces for €1 or so. Free shipping, okay, so they're cheap. Just get a pack of those. The 086P3NE, I found them here. This looks like per item, but I only need one, a bit of shipping, so a little bit more money for that one. And the diodes, I think is actually this one, but this is in a different package. So I've not been able to find the correct diode. It does read okay, so I don't really have any issue with fitting the one back on. I was going to change it just because there was other short circuits in that area. But unless I can actually find a replacement, and maybe one of you guys knows where I can get that, then I'm happy enough to put the other one back on. I'm assuming the two motors are the same as each other. So while I'm ordering the parts, I'm going to ask the technicians who are out working on this just to measure the resistance across all these pins. In fact, those pins look like the kind of direction. Yeah. So probably direction on these two, actually thinking those two arrows, sense here and voltage. So if they measure the resistance on all of the various pins, and they read basically the same, the two motors, we can say they're okay. Maybe they can tell if one of the motors is physically jammed or not. That's another possibility. So that's up to the on-site guys, really, the builder's company. I'll order the parts. I would have liked to have changed this as well, but I can't figure out what that is. Again, maybe one of you guys knows. Otherwise, by measuring the resistance on all these components and comparing, although I don't know what the readings should be, I do know they should be the same, I would say, between the two sides of this. It's quite possible actually that this thing switches these two large MOSFETs, either one or the other, which is what actually drives the motor in two directions. But without actually knowing how the motor works, I can't say for certain. But I'm confident enough that my technique of comparing was good enough in this case, so that's probably okay. Hope you enjoyed that. I'm fairly confident this one will work. Once the parts are here, you'll probably see it again in that case. Yeah. And in the meantime, I have quite a lot of other repair jobs. I have quite a few things I need to finish off, so let's go and complete a few things that we've been waiting for parts that are now here. I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.